Hi friends, we all know this very important result in trigonometry, which is sin A plus B equals sin A cos B plus cos A sin B. But how do we get this? How people got this idea and how did they invent this or derive this? Let us see how. Let us take a line OA and another line OB and another line OC. Let's assume the angle first angle is A and second angle is B. We want sin A plus B. We want the whole of this. Right? Basically, we want if there's any point P which is on the line OC, if we draw a perpendicular which will meet at M, then what we want sin A plus B equals PM by OP. Right? This is what let's say this is a right angle triangle. This is a right angle triangle because the perpendicular from here to there. A plus B equals PM by OP. This is what we want. We have to prove this. This is equal to sin A cos B plus cos B sin B. Right. Now, let's take one random point N on the line OB and draw a perpendicular from N to this one. Right. N. That let's call it NQ. This line and this perpendicular, obviously they will be parallel because they are on the same line and perpendiculars from different points, right? This line and this line are parallel. Similarly, let us draw a parallel line to this line from N meeting this line at R, right? Meeting this perpendicular at R. So we have this structure. Rn is parallel to OA or MQ. Basically, this is a small rectangle. Right. These two lines are parallel. These two lines are parallel. Right. Now, this is a perpendicular to this. That means this is a perpendicular to this also. So this angle is 90 degrees. Right. This angle is 90 degrees. Right. Now, from this point, let's draw a perpendicular to this one. Right. Let's draw a perpendicular to this point. Basically, what we do first, let's take one point P. Let's draw a perpendicular. Let it meet at N, and from there, let's draw a perpendicular Q. Otherwise, they might intersect or they might not intersect at N. So, what should let's take any point P and first perpendicular to M, and then from here another perpendicular to this line. Basically, we are from P we are drawing two perpendiculars. One perpendicular to the this line, another perpendicular to this line. Right, from that point, let's draw a perpendicular here. Not picking one random point here and projecting this. Then that might not meet also. Right, from P to M, which is a perpendicular, and PM, and PN. Then from N, NQ, and NR. So this is a rectangle. And this point, PN is perpendicular to OP, and NQ is perpendicular to OA. Now, if you closely observe, this angle, this angle, because PN is perpendicular, if we closely observe, let's assume that this angle is X. This is X and this is Y. Right. Because this is right angle, X plus Y equals 90 degrees. Right. Now, because this is again perpendicular, this angle is also 90 degrees. So this X plus this one also should be 90 degrees. So this also should be Y. Right, because x plus something should be 90 degrees. We just realized x plus y is 90 degrees. So this also should be equal to y. Right, now let's see this one. This line is parallel to this line. Two lines are parallel and there's a transversal. This angle should be equal to this angle. If this angle is y, this also should be y. But this is a, that means y is actually equal to a. Right, because these two are parallel and this is a transversal. This y should be equal to this a, and that's why because this is a, this should be a, and because this is a, this also should be a, because we just realized that angle and this angle are same. Right, this angle is actually a. Right, this angle is actually equal to a. Rest all we can forget now. Okay, I am erasing everything. We just realized this is also a. We don't want what is this, and all. It doesn't matter. Now, what is our sin A plus B? Sin A plus B is whatever this PM by OP. What is PM? PM is PR plus PM is PR plus RM. What is RM? Because this is a rectangle. RM is NQ. Right. What does that mean? PR plus NQ. PR PR plus NQ by OP. Right. That's what we can write it. Right. PR plus NQ by OP. That's what PR we have written it as R plus NQ or QN by OP. This is what we can write. That means we can expand this QN or NQ by OP plus PR by OP. Right. We are just splitting this NQ by OP plus PR by OP. Right. Now this one, this NQ by OP or QN by OP, QN by OP, let us just multiply with ON, numerator and denominator. This NQ, right? This NQ is part of this right angle triangle, right? Let us just multiply and divide this NQ by OP, this or OQN by OP, just multiply with this hypotenuse because this is part of this right angle triangle. That's what we have to prove, right? Because we want to use this right angle triangle to get some this sine A. What is this sine A? NQ by ON, right? This sine A we want, right? That is this NQ by ON. So that's why this QN by OP, this by this, let us just multiply with ON, both numerator and denominator, so that it doesn't disturb the value of the fraction. So QN by OP, we'll write it as QN by ON times ON by OP. Right? What is QN by ON? This is opposite side by hypotenuse, which is sine A. Right? This is sine A. This part is sine A. Now, what is ON? What is ON? ON by OP. This is again right angle triangle, right? Because this angle we planned it as a right angle. PN is perpendicular to OB. So this is also right angle. So this is B. ON by OP becomes cos B. Right? This is adjacent side and this is hypotenuse in this right angle triangle. OBN. So this is cos B. So this became sin A cos B. First part is sorted. Second part, again this RP by OP. What is RP? This one, RP. By what is OP? This OP. This is OP. Now, RP is also part of one right angle triangle. Right? RP is also part of one right angle triangle. We want again, we want again cos A and sin B. Right? We want cos A and sin B. So, cos A, this is the hypotenuse. That's why let's multiply and divide both the sides, both the numerator and denominator with NP. So, RP by OP, let's multiply with NP and divide by NP. Right, because this is the hypotenuse, we want cos A. I want this one. So RP by OP, which is RP by OP, let's write it as RP by NP times OP. This doesn't disturb the fraction, right? NP, both numerator denominator. What is RP by NP now? What is RP by NP? This is cos A, right? We decided this is A. So this is adjacent side and this is hypotenuse of this right angle triangle, PR. So this is cos A. Right. Now, what is NP by OP? NP is this side and OP is this one. Right. NP in this whole right angle triangle. OPN. In this right angle triangle, this becomes opposite side for this B. Sin B equals OPN by OP. Right. So NP by OP is opposite side by hypotenuse of this angle B, which is sin B, which is what we want, cos A sin B. So sin A cos B plus cos A sin B. Right. We did nothing. We did very simple thing. We took a random point on OC and drew perpendiculars to both the lines PM and PN. From this N, we again drew perpendicular to this OA and to this PM. Right. And because this is also right angle, so this plus this should be equal to 90 degrees. And this plus this should be 90 degrees. And this and this are, these two lines are parallel. So this A becomes this A. This A equal to this angle, which is also A. This A becomes this angle, which is also A. And this A becomes this angle, which is also A. Right, guys? Hope you understood this. Hope you like this. Thank you.